Alright, time for newdraftphysics.com, debatephysics.com also. But the debate continues to be, wrong time, wrong subject, wrong answers, incomplete, blah, blah, blah. So anyway, so Ian Gosling has done another video, and he, has included the improvements I have suggested, which is all very good. But he doesn't cite the reason why he's found those suggested improvements. So still quite dishonest. But anyway, and so my contention is that yes, this experiment is still flawed. That this isn't a three mass. Can't really point to that. So yeah, I could turn my arrow on. Okay. Then I have to select that. All right, anyway, that is not 3 times this. Because it's behaving as if it's a twice the mass object. At least that's what the numbers look like to me. So the idea is this, because the coming in velocity, this is the leaving velocity. So after it hits this object, it leaves, the other object leaves, and they leave what appears to be at something very similar to the same speed. All right, and the same velocity, which is also, in my opinion, consistent with what you'd expect in a 1 to 3 experiment. A 1 to 2 experiment, 1 mass to 2 mass. And then you can just look at the length of this little bar here, and I could actually count pixels. Well, I'm not going to go to all that trouble. This looks like 3 of these here, right? So it looks like 1/3 the velocity, not 1/2 the velocity. This doesn't look like enough to be 1/2, okay, of this line. So let's see. Well, let's do the pixels. Okay, 218 and 571. So that is, let's just round it off to 2 and 6. So that's 400. And what do we got here? We got 279 to 400, so that's 130. So it's, 1 to 3. So we're in there. Anyway, select please. Do I want the arrow? I'll just leave it over here, almost out of the way. It's quite stylish. Anyway, so that's enough. Right there seems a flaw to me that the frame rate, this is, it's a blur, but it blurs consistently. You can see this line gets shorter and shorter as it slows down, gets longer and longer. This is glare line. So it's a pretty good indicator of a frame, that it's the same amount of time in the frame, and this is how much glare it produces. So it's, fairly good indicator. Don't know, can't say for sure. Just saying it's a reason to doubt. And that's all I need is a reason to doubt, frankly, because it all doesn't make much sense. And what would be great is if we could see 1 mass to 2 mass, 1 mass to 3 mass, 1 mass to 4 mass, 1 mass to 5 mass, because then it gets really interesting. Because then they literally create twice the momentum. And at some point it gets to twice the momentum and can't go any higher, which doesn't make much sense either. But anyway, in the, I would argue, well, I'll do that. I'll argue with the actual, let's see, which camera is this? It's not that one. So it must be that one. I want to keep the camera. I just want to get rid of the image. Okay, get rid of the image then, Gary. I don't know where it is. I think this is it. That was it. Okay, cool. All right, so now I can draw. Maybe the drawing will be better now because it should be bigger, but now my lines will be smaller, thinner. But anyway, we'll see how it goes. All right, so you start with the idea of a 1 against a 1, and that one's pretty obvious, right? You get momentum in, MV, and you get exactly the same MV out. Okay, going this way. And so everything looks perfectly fine. Okay, MV in, MV out. The universe is rational. Oh, that's really out of center. Alright, so I just have to learn how to draw crooked. All right, so then we're just changing it to a 1 mass hitting a 2 mass. Okay. And my argument is that what happens when they reflect, so we're going to say, we're just going to draw the reflection. So it's always the same in. So the same 100, let's say, goes in, get 100 out in this case. All right, and so now we're just going to do the same thing, 100 in, and what happens on when they hit. And when they hit, so part of the energy goes this way, and I would say it's 3/4 of the energy, 2/3, and 1/3 goes back this way. So 2/3 times 2 masses, so obviously they're both going 1/3 the initial velocity. Okay, that would be what I would say would happen. Now, Professor Lewin does this with the air cart track, and when they do it with carts, they have a spring in here, okay? And springs change the experiment. So even though they're both called elastic, it's technically really not an elastic experiment when you've added a spring. It's a super elastic. And what you'll get is, you'll get this plus, because the spring is going to give half its energy this way and half that way. So it's actually going to make this more than 2/3. And this will obviously end up being less than 1/3 because a part of the energy is going to be used in the spring to push this one further, faster. But anyway, we don't have to worry about that. No springs here, so not a problem. So in my opinion, the 1 to 2 experiment, okay, creates the same velocities. The two things leave the center point at the same velocity. All right, and then the 1 to 3, which is the one he's claiming he's doing, right? But we don't have any evidence that he's actually measured it. He said he did now, and it came out perfect to 1 to 3, but we didn't see how he measured it. He said he didn't have a scale, so he obviously didn't do it that way, or he would have just said, I used a scale. So who knows, and who knows how correct it is. All right, so anyway, my prediction in this case, okay, would be that the 3 object, all right, has to only get 3/4, okay, of the momentum, and this gets, no, okay, it can't get 1/4, no, it gets 1/2, the momentum goes this way in a reflection, and only half the energy goes in here, all right, so you get something like 1/6 the velocity, all right. Would be how they won't go away at the same velocity. This will clearly, the rebound will be clearly a higher velocity than the 3 mass will leave. So it won't be this 150 thing they're claiming. Momentum's out and 50 back this way for a total of 200. So we put 100 in and we get 200 out is their argument, that's how the physical universe works. I can turn 100 momentums. I can turn 100 in the direction, right? I have 100 going this way. I can make 150 out of it for free in that direction. Yeah, there's a little bit of a rebound this way, but who cares? I don't have to collect that. I can just keep increasing the momentum in a direction, and they say that's a thing. You can do that. I say it's not a thing because we don't use it. Jackhammers don't use it. Nothing uses it, so it's a way to make free momentum, so why wouldn't they use it if it was a real thing? That's sort of the simple argument. All right. And then the 4 mass. Okay, so 1 on 4. The prediction would be is now you're going to get a big reflection, so 3/4 now of the momentum. It's going, or 1 or 2/3. 2/3, I guess, is the right answer, right? Yeah, 2/3. 2/3 goes back as a reflection, and you only get 1/3 in this direction, which means now you're going like 1/12th, 16th of the velocity. The 4 mass is now going to go really slow, and then you get to 5, and now it's getting really close to your, whatever, 100% this way, okay, and 0 this way, something close to that. It's a finite thing, right? There's a point where it doesn't move at all, and there's a point where it moves something. So they say there's this magical point where it's 99% of the energy reflects, and then there's a point where it's 100%. And I'm arguing if it's 100%, then this thing isn't going to move. If this thing moves, then it's not going to be 100%. So anyway, but that would be creating twice the momentum in the same direction. So they're literally saying that you can put 100 momentums in and get 200 momentums out. So 100 comes in, 200 comes out. That's their theory. Now I'm saying that's doubtable, and they keep insisting, no, it must be true. And they say their experiments are good enough to say it's been proven or it's a conclusion or any of that crap. Let's see if I can improve that at all. That's probably a little better. Yeah, I have to work it out. Yeah, I mean, it's almost the right size. I mean, the focus looks a little better. It's still a little blurry, but don't know what else to do. But I think that's an improvement over the last video anyway. Alright, so I guess we'll go to a comment. So I'll have to pause to find that. Alright, appear to be in the right place. Don't click anything. It's always... Anyway, so the channel 321 guy, okay, still commenting. So he commented on my last video about the balance. So I'll read it, what the hell, as I responded to it. I'm not sure if the oscillating lever has any relevance here. So just amazing. It's not, it's insanely relevant in the sense it's a balance and it's an oscillator. And the only way oscillators can continue to oscillate is they has to do something symmetrical, something consistent. It can't do something inconsistent, or it would be losing its energy. It would be moving in space. It would be doing something. So when an oscillator is doing the same thing back and forth symmetrically, there must be the same energy moving back and forth in that system. There's no other rational way to think about it, I don't think. And you certainly didn't challenge my statement that there's no other rational way to see it. All right, here, because it's just a pendulum. It's not just a pendulum. It's ridiculous. It's a pendulum with two different masses stuck on it in different positions. Okay, they're moving with different angular velocities. And it's their angular velocity that is going to have to be compensated for. That is, they have to be pushed in space by the lever. The lever has to... one side has to get heavy, right, and then make the other side lift up. It has to happen. All right, but using your logic, doesn't it show that a 4 mass 1 height is the same as 1 mass 4 height? No, it doesn't, because height's not relevant, and it's not moving, by height, by distance. It's not moving in a free fall situation. So, as I point out. But clearly, it's not about the height, it's about the velocity. It's 4 times the velocity. The height in this case is not like gravity. Gravity, you're only going, you go 4 times the distance, you're only going twice the speed. In this case, you go 4 times the distance in the same unit of time, you're obviously going 4 times the velocity. If you go 4 times the distance in the same time, that's 4 times the velocity. So I point out, as usual, you miss the point and have no relevant counter-argument. What the balance clearly proves is that a 1 mass moving 4 times the velocity is created by the same force as a 4 mass moving 1 velocity. The same force creates both objects. So I can create either object with the same force, indicating one can't have 4 times the kinetic energy. Heights are irrelevant because nothing is in free fall. Okay, so we'll go back to his answer to a previous question I asked him regarding this banging stuff in. And so I said the 600 momentum mass weighs 1 kilogram, the 650 mass weighs 3 kilograms. What would happen in that circumstance? There's a 50 mass difference, and I was expecting an answer that was the same, consistent with what we see in these colliding pendulum experiments, which is when the two objects hit each other, the heavy thing stays still and the light thing flies away. And so he didn't apply that same rule. So he didn't do what Newton said was just subtract. What they're claiming is Newton's idea, which isn't Newton. That all you have to do is subtract directions, and whatever's left over is what you get out. And it's not that simple. You don't get out whatever's left over. It won't work. So as I've previously stated, you can't conserve. Anytime you have a difference in the masses, you cannot possibly conserve kinetic energy. Can't happen. So whenever you switch energy from light masses to heavy masses or heavy masses to light masses, you will always either create or lose kinetic energy. You can never conserve it. All right. So he says, so he quoted me as saying Newton didn't require that, which was requiring, I can't remember what the point was, but it doesn't matter. You are saying that Newton had a way to predict what happens in a collision based on a pre-collision momentums only. I'm saying that's what the simple statement you quoted, which was just subtract. You said they subtract. You say opposite directions subtract. So all you have to do is subtract the opposite directions, and then you have a net left over. You're claiming that the net left over can or doesn't have to include the original momentum. So you're just changing the rules. Well, he didn't. That's not possible. So again, bullshit. Anyway, the 600 mass weighs 1 kilogram. Okay, what's happening? That's my question. Okay, I already read that. Elastic collision, right. Well, I already made that clear. Both objects will change direction. So in the case that we're watching with the pendulums, both objects don't change direction in the sense that when they collide, only the light object flies away. The one mass will have a speed of 625, and the three mass will have a speed of 191, blah, 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 which is not conserving the momentum. So you start with 1225 momentums, and you finish with 1100 and something. Now the individual absolute momentums are 625 and 575, right? So you've lost 50 momentums. The difference is still 50. You lost 50. The difference is, yes, that you lost 50, that you're missing 50. You didn't conserve the momentum. But anyway, total momentum was conserved. So that's just such a lie to say total momentum was conserved when clearly the total momentum wasn't conserved. All right, in the modern sense of total momentum, I don't know what, there's no point in using the word total if what you mean is net difference. Because if you bent fenders, you're not going to use this rule. So if it wasn't elastic and instead you were bending fenders, you're not going to apply this silly rule. Because it won't work. Kinetic energy isn't going to show up anywhere if you're bending fenders. You're not going to be able to bend the fenders with this kinetic energy bullshit. And certainly you're not going to not bend a fender with that extra 50. You're going to bend that extra 50's worth of fender. All right, assuming elastic collision and conservation of Ke allowed us to solve the post-collision velocities. So solve them how? By not conserving either one. So you didn't conserve either the momentum or the kinetic energy in your prediction. All right, there are online calculators you can use. So what's the point of that one? Isn't that kind of a joke? An online calculator that's using the same stupid formula that I say never gets a right answer? Oh, that's just so brilliant. Let's see, to solve these kinds of problems, but of course it's better to understand the theory first. There's no way to understand your non-conservation of momentum theory, your free momentum theory. There's no way to understand it. You can make things happen without using anything called momentum. So something with no momentum can cause something else to have momentum. Somehow you can increase or abolish the existence of momentum. And I'm saying, no, you can't. Professor Lewin said, no, you can't. Now, I could play a Professor Lewin clip, where he starts talking about how you should have a sleepless night. So he's describing this, he's taking this fact, this pendulum experiment, to its conclusion, and ultimately a non-moving object. And he clearly points out that, okay, you have 100 momentums go in, and the non-moving object has 200 momentum in it. But it's not moving, right? So somehow it has an MV, but it doesn't have any V. And his claim is I think, that the whole Earth moved. So whatever you have the wall tied to, that caused the whole Earth to move. Now, the simple argument I'm making is that once something can't move, the reflection happens very quickly at the surface. Once you hit an object that's too dense to move, it says right there at the surface, it says, oh, this thing isn't working. These atoms cannot move. Okay, the substance is too hard and I can't move them, and it just reflects. So when you have a steel anvil, you're not putting 200 in and then it bounces, and then 200 goes in and it bounces, and then 200 goes in and then it bounces, and then 200 goes in and it bounces. That is not happening. You're not putting 30 or 40 or 50 times the momentum into the object that you have put into the ball. So the idea that you get a 100% reflection from something that absorbed twice the energy you started with, that is twice the momentum. So you throw a tennis ball with 100 momentums. It hits the wall, moves the wall with 200 momentums, and comes back to you to start over again, right? In the Newton's cradle, in a Newton's cradle, the tennis ball is coming back. So the tennis ball goes in, all right, causes 200 momentum to go that way. The tennis ball goes back up and can hit again. So I've described this experiment, I could do it. This is a way of kind of understanding how this can't be true. It can't be true. Come on. There's no logic to this nonsense. So I could make, this is my invention, so I'm patenting it now. This is my patent. Okay, my description of, I own it. Okay. So you just make a device where you can just, put your, let's say it's a 4 mass or a 5 mass that ends up with 200 the momentum, and I get a full reflection. So that is, I get almost 100%. I get 90% of my energy back at least, 95%, whatever. So, so I swing in the tennis ball, the 100 momentums, okay, swings in, hits this, okay, heavy thing, and shoots it with 200 momentum. So I got 200 MV. I put 100 MV in, all right, and so this is what they call conservation of momentum. So I put 100 MV in, I get 200 MV out, and I get a full reflection, so the pendulum swings back. Now, while it's swinging back, okay, I do the logical thing, and I just push another ball into the, this is a feeder. So the feeder just pops another 4 mass there. All right, now the 100 comes back, or let's say 97. Okay, and yeah, I get 189 momentums. All right, another ball leaves with 189. So when I'm already left with 200, now I got 189. Now I get another rebound. All right, comes back, and let's say it's only got 175 now. It's only got 75 now, right? So now I only get 150. Okay, but yeah, it's a real 150. Okay, so I got 200. So I shot 200, a bullet, a heavy bullet going with a heavy momentum. I just start with just 100 MV, and now I have 200 plus 195, let's say, plus 150, and it's plus 100. I'm going to make it decline quicker, and then plus 75, and then plus 33, whatever. I can add all of this up, and I'm going to end up with something like 1,500. So I start with 100 momentum in, 100, one ball moving with 100 MV, and I'm going to end up with 7 or 8 balls moving with 1,500 MV in that same direction. And you're saying that physics, the scientists have not figured out how to capitalize on that free, okay, multiplier. That thing that can hugely multiply the amount of energy that's coming out, the amount of electricity. Like I said, if this was, you're using electricity to create it, and you were collecting the electricity you could create. So these were magnetic objects or something, and you could collect the amount of force it takes for the thing to go through a coil. And so each one of those coils would be creating you could almost use like braking, and just consume the energy through the fact that you're going to put it through a coil, and electrified coil, and it will do the braking thing, and you can just collect the extra back current. And so you could collect 1500 watts, and you put 100 watts in. So you put 100 watts of energy in, and you get 1500 watts of energy out. That's what you're suggesting. There shouldn't be any conversation about that. It's somehow a proven fact. That's how it works. That this device is makeable. That's your argument. I can make this machine easy. And I'm arguing it'd be pretty easy to collect this extra 1500. All right. So that's why I'm saying you're going to have to overcome this evidence of, you're either going to explain how my machine won't work, or you have to explain, well, that's what you have to do. You have to explain how it won't work. And it's so simple. I don't think you can explain how it won't work. So I think the conversation should be over, and you should concede whatever Ian Gosling's doing, it's got some bullshit on it. All right. So that should be enough, I guess. So till next time, we'll see if anybody has anything to say. Otherwise, I'll just keep making some more argument videos and see if anybody can make a counter argument to any of the numerous ways you can prove the paradoxical nature of what's being asserted. And the balance was the first video, and I guess I can just do the 5-ton, 10-ton train thing, and then I can do the ballistic pendulum thing, and the bowling thing, and just keep explaining how, if it was real, why can't anybody capitalize on it? If your kinetic energy is a real thing, why doesn't it work in any real circumstance? All right, so till the next time and such, and so forth and whatnot. Yeah, but I think that's enough. So anyway, the image is still kind of blurry. All right, so maybe I gotta go with half that size. The lines are a little thinner now, but yeah, it's really just not good enough. Damn it. I wonder if these dry erasers, maybe they'll draw on paper. Well, yeah, it's not terrible. I could probably get away with doing that. Because they don't seem to work as well on the board. Alright, so anyway, we'll work on it. Oh, you don't need that. So, till the next time and such. I don't think there's anything really important there. No. Yeah. Just tests. Paper tests. So, till the next time and such.